Hi everyone, this is Miss Ward. Tonight we're going to be talking about our Newton's Law unit, concept 3, Newton's second law. And this is where we're going to really get into the meat into the equations that we're going to be using, or the equation we'll be using throughout this unit. I do have my son again with me, so if you hear small baby grunting noises in the background, you're just hearing the little baby. Alright, so this basically jumps right into what Newton's second law says. If I were to ask you what Newton's second law says, all you would need to tell me is that force equals mass times acceleration. F equals ma. That equation in itself is Newton's second law. Acceleration is caused by a single force in the form of an equation would look like acceleration equals the force divided by the mass. This allows us to look how force and mass are related to acceleration. So notice that acceleration is proportional to the force. So as the force gets bigger, so does acceleration, and it's inversely proportional to the mass. So as the mass gets bigger, the acceleration gets smaller. Rearranging that equation gives us the better known equation, F equals ma, and that in itself is Newton's second law. So the direction of acceleration is always in the same direction as the force, and we generally measure that force using a unit called, no surprise, newtons. The unit, when we talk about force, you're looking at mass, which is in kilograms in SI units, and acceleration, which is in meters per second squared. So we have a very large, mix of different units, and one of them's in kilograms, the other one's in meters, seconds, so they're not all in the same, not really, I don't know what the word is, they're not in the same magnitude, that's the word. They're not all in the same magnitude, and so it can get rather confusing, so Newton just said, we're going to mash them all together, but instead of using that long, confusing unit, we're just going to call it a newton. So a newton is defined as the force required to give 1 kilogram mass and acceleration of 1 meter per second squared. So, in other words, 1 newton is equal to 1 kilogram meter per second squared. So, looking at a quick example, an 1800 kilogram car has an acceleration of 3.8 meters per second squared. What is the force acting on the car? Alright, so we're going to use our equation F equals ma. Alright, we're looking for our force, so that's what we're solving for. So force equals the mass of 1800 kilograms times the acceleration of 3.8 meters per second squared. So 1800 times 3.8. And we get the force equals 6840 kilogram meter per second square, which is a newton. Looking at this problem, I see that I should have two significant figures, so that means I need to round this. So my force equals 6800 newtons, and that is my final answer. Nothing complicated, nothing hard. These F equal ma problems can be super simple, so don't overthink them. Alright, so it's important to know that Newton's second law applies in both a single force and a net force situation. In general, there's going to be several forces acting on a given object. The sum of the forces, which is the net force we talked about in concept 1, on an object is equal to its mass times its acceleration. So there's ways you can write this. Sometimes generally I always just write it as F equals ma, and I expect you to know that force means it's the net force. Okay, it could be one force, it could be the result of many forces, it just depends. Sometimes you might see it written like this, which that is the Greek letter sigma, and in math that means sum. Okay, so the sum of the forces equals the mass times the acceleration. So occasionally you will see it written like that. If you ever see that, don't let it throw you off. It's just telling you that it's the net force. It's the overall force. I like writing it in just the F equals MA because I think it's easier. I think it, is less cluttered, and it makes as much sense writing it that way as it does the other way. But all right, that's it for tonight, guys. Make sure you go online, you do those WISC. Make sure you guys have at least looked at your practice problems. Start, working on those. Don't wait to the very last minute. I know at the last unit that was a bit of a struggle for some people. If you have any questions, please let me know tomorrow. Have a great night.